Hi Pre-Calc, this is video number 3 for our next problem, r equals sine theta plus 2. We're going to do this one and one more, and hopefully that'll be good and get you some good foundation here to practice some on your own. So r equals sine theta plus 2, I want you to do what we did on the other examples and start with your rectangular equation. So y equals sine theta plus 2. And so if you recall, this shifts up 2. We have a nice sine curve, and we want to go from 0 to 2 pi. So here is our graph, right? From 0 to 2 pi. We have our 5 key points in here, and those are the key points we want to be able to plot on our polar coordinate plane. So if you notice, I have our midpoint is at 2, our max is at 3, and our minimum is at 1, right, for radiuses. And then we have 0, 2 pi, pi over 2, and 3 pi over 2. Okay, so let's go ahead and mark on our polar coordinate the rings so they kind of stand out a little bit, right? So our maximum is 3, and then I just wanted this bold enough for you to see, so I've highlighted them. Okay, so let's go ahead and start plotting. So we have a radius of 2 at 0 radians. So here's our first point, a radius of 2 at 0 radians, okay? And then our second key point, we're just going to go across the coordinate plane, is going to be pi over 2. And so that radius is 3. So here's pi over 2, and our radius is 3. So I'm going to plot this point up here at a radius of 3. Now what's happening between 0 and this radius, right? Between 0 radians and pi over 2, this radius is increasing a little bit, but increasing. So the radius is increasing, this distance, right, is increasing a little bit until we get to a radius of 3. So if we can draw this shape in, actually, let's see, I want this one. If I can draw this shape in here, I'm just making a nice smooth curve from one point to the next. You see that in blue there? Hopefully you can see that ever so slightly. Your curves will be nicer. And then I'm going to go to my next key point, which is pi, a radius of 2 with pi radians. So that's over here. Here's pi. I'm going to plot my next point over here with a radius of 2. Now let's go ahead and continue. Our radius is getting smaller here. So we're going to continue right over here. Let's go ahead and get our line again. And we're going to make a nice smooth curve all the way over to here, right? Okay. Now yours are better than mine. And then our minimum value over here is at 3 pi over 2, 1. So here's 3 pi over 2 and 1. So let's go ahead and put that last point right in there. Okay. And then we'll go ahead and connect this. The radius is getting smaller from pi to 3 pi over 2. In this region right in here, our radius is getting smaller, right? That's the measure of my radius. So let's go ahead and get our line connector here and connect this from here to here, right? And look, it's not a circle at all, actually. It's a slightly different shape, and I honestly forget the name of it right off the top. I believe it might be a cardioid. Looks, ooh, that's terrible, but you get the gist. Let's go ahead and look at a much better shape when we're looking at Desmos, because you can put this on Desmos. But here's my shape, right? It looks kind of like a heart. I believe that's a cardioid. And let's go ahead over here and look at that. So there's our shape. It's indented a little bit here. This is kind of a nice one to draw. Looks circular, but then there's an indent, right? And it's not quite a circle because the radius changes set from the origin or the pole. Okay, so I'm going to pause it now, take 30 seconds, summarize with your partner, and let's do our last example together.